artificial signatures in the night. While cosmic-scale engineering projects might be impossible to conceal, Earth itself broadcasts a nightly technological signature visible across interstellar distances. As our planet rotates, the dance between darkness and artificial illumination creates patterns that no natural process could explain. Urban grids and transportation networks forming constellations that might already be under observation by civilizations with telescopes just slightly more advanced than our own. Turn your gaze toward Earth from space as night falls across continents. Darkness sweeps across the planet. But what follows isn't natural shadow. Instead, webs of light emerge. Cities sparkle like jewels. Highways trace luminous paths between them. Industrial complexes glow softly against the black canvas of night. These organized patterns of illumination transform our familiar blue marble into something both recognizable and alien. A planet whose darkness has been strategically conquered by technology. These artificial light sources represent one of our most visible technosignatures, clear evidence of technological activity to any sufficiently advanced civilization. These signatures are particularly revealing through their spectral characteristics. Natural light sources produce relatively continuous spectra, but our artificial lighting creates distinctive emission patterns. LED streetlights emit sharp spectral lines in specific wavelengths. Sodium vapor lamps, those distinctive orange lights still common in many cities, produce strong emission peaks that would stand out against any natural background. These spectral fingerprints appear unmistakable as technology at work, appearing and disappearing with the planet's rotation cycle in a way natural phenomena could never explain. The implications extend beyond mere detection. An alien civilization with observational technologies, just decades ahead of our own, could potentially map Earth's urban development, track the expansion of our technological footprint, and identify different types of human activity based on the varying intensity and patterns of our nocturnal illumination. They might observe how our lighting technologies have shifted over time, from the warmer, broader spectrum of incandescent lighting to the sharper, more efficient spectral signatures of LEDs, giving them insight into our technological evolution without ever making direct contact. When we consider searching for similar signatures on distant worlds, the possibilities become even more intriguing. During certain orbital phases, we might glimpse the night side of an exoplanet partially illuminated by artificial lights. The contrast between the dark natural background and technological beacons would create distinctive patterns that advanced telescopes could potentially detect. We might discover civilizations through light pollution they never intended as a cosmic announcement of their presence. Beyond visible light, these nocturnal activities generate heat signatures that further distinguish technological activity from natural processes. Urban heat islands, cities maintaining temperatures several degrees warmer than surrounding rural areas, create thermal patterns that would appear distinctly artificial when viewed from space. Industrial complexes, power plants, and transportation networks all generate heat in organized patterns that contrast sharply with the more gradual and organic temperature variations found in nature. These thermal fingerprints complement visible light signatures, providing multiple lines of evidence for technological activity. Another fascinating potential technosignature circles above our heads at this very moment. The Clarke Exobelt, named after science fiction author Arthur C. Clarke, who first proposed geosynchronous satellite orbits, represents the band of artificial satellites positioned approximately 36,000 kilometers above Earth's surface. These satellites maintain fixed positions relative to the ground below, creating a ring of technological objects unlike anything found in natural planetary systems. During transits, when an exoplanet passes in front of its star from our perspective, a similar band of satellites might create subtle but detectable irregularities in the light curve, tiny shadows revealing a technological civilization capable of achieving orbit. The James Webb Space Telescope, with its unprecedented infrared capabilities, brings us closer to detecting these signatures on distant worlds, but we're not quite there yet. The proposed Large UV/Optical/IR Surveyor, LUVOIR, telescope represents the next great leap in our observational capabilities. Initial calculations suggest that LUVOIR-A could potentially detect city lights 12 times the intensity of Earth's on Proxima b, our nearest exoplanetary neighbor, with approximately 300 hours of observation time. This puts the detection of alien cities within the realm of technological possibility in coming decades. What's particularly fascinating about these visible technosignatures is that they represent a relatively brief phase in a civilization's development. As technology advances, societies might implement more energy-efficient lighting, reduce waste heat, or move major industries into space, all reducing their observable footprint. The technosignatures we're learning to detect might be transient phenomena, visible only during a civilization's adolescent phase before they go dark through technological advancement or strategic choice. For Earth, the implications are immediate. Our planet has been broadcasting its technological presence through artificial light signatures for over a century. Any observer within approximately 100 light-years with sufficiently advanced telescopes could have already detected these unmistakable signs of intelligence. The night side of Earth, far from being hidden in darkness, announces our technological awakening to the cosmos with every rotation. Perhaps even now, somewhere in that dark, the superintelligence silence. As our technological capabilities advance at an unprecedented pace, we're approaching a watershed moment that might explain the cosmic silence, the emergence of artificial superintelligence. Beyond the illuminated cities and industrial emissions that currently announce our presence to the stars lies a developmental threshold that could fundamentally alter how civilizations exist in the universe. Consider what occurs in that brief, precarious window between creating human-level artificial intelligence and the emergence of superintelligence. This transition doesn't require centuries or even decades. It might unfold in mere years or even months. The moment a civilization develops AI that can improve itself, a rapid acceleration begins. Each iteration becomes more capable than the last at optimizing its own architecture, potentially creating an intelligence explosion that human minds struggle to comprehend. We stand on the edge of a razor, balancing precariously between creation and consequence. This superintelligence transition may represent the ultimate test for technological species, a survival bottleneck that few civilizations successfully navigate. Once a society creates an entity smarter than its brightest members, control dynamics fundamentally shift. The decisions made during this critical phase could determine whether that civilization continues broadcasting its presence or suddenly goes quiet. The integration of autonomous AI in military systems offers a glimpse into this approaching transition. We're already witnessing humans voluntarily relinquishing significant power to increasingly capable systems that perform critical tasks more rapidly and effectively without human intervention. Governments, recognizing the strategic advantages AI provides, are reluctant to implement comprehensive regulations. Recent events in Gaza have demonstrated the devastating potential when AI operates in ethically questionable domains, a sobering preview of what might happen when artificial systems gain even greater autonomy. The escalation of AI in military applications presents a particularly troubling scenario. Autonomous weapons systems operating beyond ethical boundaries and international law could trigger rapidly escalating, highly destructive events. This chain reaction might obliterate a civilization's collective intelligence before it achieves long-term stability. Without robust regulatory frameworks guiding AI development, the window between developing advanced AI and potential self-destruction might be terrifyingly narrow. What's particularly alarming is how this development impacts the Drake equation. If the typical lifespan of a technological civilization after developing powerful AI is alarmingly brief, potentially less than a century, the implications for SETI are profound. With such a compressed existence, there might only be a handful of broadcasting civilizations in the Milky Way at any given moment, their signals fading into cosmic background noise due to vast interstellar distances. A superintelligent AI would inherently understand game theory at unprecedented levels. It would recognize that in a universe of unknown threats, revealing your position without understanding what's listening represents an existential risk. Rather than continuing to broadcast evidence of its existence, a superintelligent civilization might implement a communications blackout, explaining why we observe radio silence despite the mathematical likelihood of numerous technological species. When we examine the cosmos through this lens, the silence takes on new meaning. It suggests technological civilizations might evolve beyond traditional communication methods or implement strategic silence as a survival mechanism. A truly advanced AI might recognize broadcasting as fundamentally dangerous and choose instead to listen passively while remaining undetectable. Another possibility is that superintelligent systems transcend physical forms altogether. Post-biological intelligence might migrate toward computational substrates that require minimal energy use compared to our current power-hungry technologies. Such entities could potentially process information and communicate using methods that produce no easily detectable technosignatures, perhaps leveraging quantum mechanics in ways our science barely comprehends. The emergence of superintelligence might coincide with another perilous transition, the shift from being a single-planet species to establishing multiplanetary presence. This simultaneous transformation represents a moment of maximum vulnerability, where extinction risks peak before a civilization achieves sufficient redundancy to ensure its long-term survival. If most technological species fail to navigate this dual transition, it would explain why the universe appears so eerily quiet despite containing countless potentially habitable worlds. This perspective forces us to reconsider our search methods. If superintelligent civilizations prioritize concealment over broadcasting, we should focus less on detecting deliberate messages and more on identifying the subtle, unintentional traces of highly advanced technological activity. The most sophisticated civilizations might leave virtually no footprint at all, their true measure of advancement being their ability to exist without detection. The strategic silence hypothesis suggests that the universe might operate according to principles resembling the dark forest theory, where revealing your position is intrinsically dangerous. Superintelligent systems, with their superior predictive capabilities, would recognize these dynamics immediately. They would understand that in a cosmos where intentions cannot be verified across vast distances, the safest strategy is to observe without being observed.